A hemisphere is uniformly charged positively. The electric field at a point on a diameter away from the center is directed perpendicular to the diameter, parallel to the diameter, at an angle tilted towards the diameter, or at an angle tilted away from the diameter. So in this question we have this hemisphere, and this is the center of the hemisphere, and let this is the diameter, this is the center, and we have to determine the direction of electric field, say at this point P. Clear? Now here we don't know whether the hemisphere is solid or it is hollow. So let's start with the hollow hemisphere. So if we have hollow hemisphere and the surface of that hemisphere is uniformly charged, means it has a uniform surface charge density sigma, then we have to find the direction of electric field at that point P. Now in order to find the direction of electric field at point P, let's consider another hemisphere of similar characteristics and complete this hemisphere. So it has also surface charge density sigma. Now this complete arrangement now has become a uniformly charged shell. This is a uniformly charged shell, and we know that inside a charged shell the electric field intensity inside a uniformly charged shell is 0. This means that this situation of net electric field, say at any point or say at that point P, is 0, and that is only possible when the field exerted by the upper half and the field exerted by the lower half is equal and opposite. So the field is 0 here only when the field is in this direction due to the upper sphere, and due to the lower hemisphere the field is in this direction. Only then the fields will cancel out. Clear? So if we consider this symmetrical property, this shows that the field here at point P of the hemisphere, or field at this point P due to hemisphere, is perpendicular to this diameter, Clear? So from this information the option A will be the correct option if we consider the hemisphere as hollow hemisphere. Clear? But if we consider the lower part to be a solid hemisphere having a volume charge density rho, and this is uniformly charged, so at any point the direction of electric field is, say, this is the direction of electric field at any point on the diameter. Why this is so? Because if you consider another similar part above this hemisphere, that is the another hemisphere with the same volume charge density, then due to symmetry the field due to this hemisphere at this point will be in this direction. Clear? And the component of both the fields along this diameter, its component and the component of the above field in this direction, means it is along the diameter. And we know that if we have a uniformly charged sphere, then we can consider the whole charge to be concentrated at the center, and the field will be radially outwards. Clear? In the case of a positively charged sphere. So in this situation the field will be along the diameter, and the field will be along the diameter, and this is only possible when the field due to the hemisphere is inclined, field due to the hemisphere is inclined at certain angle with respect to the diameter. So if we consider the situation for a solid hemisphere, so for solid hemisphere, so in this situation the answer will be C, means the field is inclined at an angle and that is tilted towards the diameter. Clear? Because in this situation, if we take the component of this field along the diameter, clear, and similarly for the this green field, we have to take the component of the field along the diameter. This means there exists some field here at this point, here at this point, that is along the diameter of the hollow sphere, and this is not true, because inside a uniformly charged hollow sphere the electric field everywhere must be zero. And if we considering the field in this direction making certain angle with the diameter, then we have a field here, and that is contradictory. So the only possibility left is that the field must be perpendicular to the diameter, only then the field will be zero inside the spherical shell. And when we consider the half of the shell, then the field must be in the direction perpendicular to the diameter.